Good evening. I think some of the people in the audience have had the chance to share some of these reflections with. And pardon me if you have heard me talk about this, but I'm also adding my latest reflections around the same subject of leading from the emerging future. The first thing I would like to say here is that leading from the emerging future is around just the slides. They're not able to move. Put them. Yeah. Okay. Thank you. That we need a deeper learning cycle. Much of our education system, and probably this is only speaking to my age, is that we are trained, educated by reflecting on the experiences of the past. In a way, this has served us reasonably well. We stop to observe our actions, reflect on the observations we are making so that we can plan and then continue to act. This is also known as the Kolb method of learning. It has served us immensely well. The challenge is what if or when we do not have enough equivalents in the past, good enough equivalents in the past to learn from. So working with colleagues at MIT and in the Presencing Institute, we were talking to people who we believed had brought about deep and profound change. And that was when we noticed that they were working with another learning cycle. And this cycle is what we are calling learning from the future as it emerges. We coined the term presencing to describe how that happens. The term presencing hasn't found itself yet in the English dictionary because it's a coined one recently. It simply means the capacity to be fully present in the here and now, while at the same time sensing what is on the horizon. This move of being present and sensing at the same time is what we are referring to as presencing. And these innovators, change makers, leaders of profound change are the ones that gave us this kind of inspiration to create the term presencing. Another way of looking at this is simply this, that we do focus on things out there. We aim for the stars. They also, the people I'm talking about as innovators and change makers, also do that same thing. But this gesture of moving like that also means they seek to know the world not as they wish it to be, but as it is. Its beauty and ugliness, they take it in. And then the second gesture of the same move is simply this, the capacity to bend the beam of observation on the seer, the capacity to see the seer. So while this is important and we do this quite easily, sometimes we are less adept at bending the beam of observation on the seer. This act of both shooting for the stars and bending the beam of observation on the self allows us to connect with the future, and then we act in the present to make the future a reality. And for me, this is where innovation comes from. Obviously, the bending of the beam is easier said than done. The simple word for that is also self-awareness. I was once in a small class and our professor walked in with a very sad, long face and he said, "You must have heard the sad news that I have been transferred. I know how sad you must be feeling. These things happen. I hope they bring you someone as good as I have been. And with the same sad, long face, he walked out of our class. And as soon as we knew he couldn't hear us, we looked at each other and went, hooray! Whatever gave him the impression that he was the best thing that ever happened to us, we will never know. So what am I saying here? When there is this dissonance between this is how I see myself and this is how other people see me, there isn't a better way of being more ineffective than this. Obviously, this is true about all of us. The real deal is not in that this exists. The real deal is whether we are aware and are constantly trying to make these align. They will never be like this, but the sheer awareness puts us in a better position. So we saw that these change makers who were able to access the emerging future worked in this way. They had core movements that they worked with. They often gathered a diverse group of people. A diverse group of people, they never wanted to do inbreeding. If they are geographers, then they looked for mining engineers and they looked for ordinary farmers. They looked for different people and they came together to sense into the challenge that they are seeing or sensing or the opportunity they want to unravel. And then they don't engage in a debate in their four walls of their offices. They go out there to sense the field, because the clues to the future we want to create are not in the debating room. They lie out there to meet different people, people who are on the front end. These, they called them experts. Obviously, people who have spent time in school like you and I for a long period of time are experts, but they never limited themselves in terms of who they called the expert. Everybody who is at the front end of that is recognized as an expert. If you are researching on hunger and I'm suffering from hunger, I'm an expert for you. If I'm raising a child who is struggling to go to school because of various reasons, I may not have a PhD, but I'm an expert at how to work with young children. So they went to these frontliners to get the knowledge. And then after they did that, what was the next move? It is not that thing we do when we are in business school. They don't start interrogating the data immediately. They retreat. They retreat in order to allow inner, deeper knowing to emerge. And they ask themselves two key questions. Who am I and what is my work? Who am I does not need a response, Martin Kalumbanda. Who am I simply means this. Who is the better version of me if I wasn't petty? And if it's we, who are we? Who is the better version of ourselves that we can become? And by what is my work, they didn't mean the job description. They simply meant, what am I here on earth for? They asked the purpose question. What am I in this community for? What am I in this university for? And this combination of two questions allowed them to tap into a different form of knowing. And in that reflection, some impulses occurred. Some strong pull occurred. And again, it's not the time to interrogate, is this a good idea or not? They would only pick the strongest impulse and act in an instant. There are times when our hands are wiser than our heads can ever be. And when they acted, then they can bring all those capabilities for interrogation, for challenging, for analysis. Why did we get these results? They would never interrogate what is coming from the bottom of the image I'm showing you here. Interrogation, data analysis came after they had taken the first action. Because if you start interrogating the impulses from deep reflection, you can only produce reasons why you can't go ahead. And therefore, the likelihood of tipping into analysis paralysis. And what they are learning from this experimentation is what they then, as lessons, feel could help in the scaling up, in institutionalizing the lessons. So, in a way, what I'm saying is that there were these three core movements. First of all, it's attention. In a world where so many things are pulling on us, our attention can be dissipated. But for these people I'm talking about, they cultivated deep and quality attention. When decision makers and leaders and researchers are not able to attend to something with depth, then they are just floating on the surface here, and we don't see the systemic forces that are holding the issue in place. Quality attention gives birth to intention. Something gets born as we see more than meets the ordinary eye. And then intention makes agency as natural as breathing. In moments like this, when the world is in what some of us might think is chaos, we can feel completely isolated, individually and sometimes collectively, and we lose our agency. And that's why, for me, a gathering like this is brilliant, because it responds to what a scientist by the name of Ilya Progagain says: in a sea of chaos, islands of coherence have the capacity to bring balance to the system. So us gathering like this and spending time to think together in a time of chaos, we might just be part of the islands that are needed to rebalance things, and maybe to find our way in a new world. So to do that, we need to tap into more than just the traditional sources of intelligence or knowing. We need to tap into at least these three intelligences: the intelligence of the open mind, the intelligence of the open heart, and the intelligence of the open will. Yes, much of our training in universities and colleges focuses on what is above our shoulders. That is not sufficient to access the emerging future. We need to switch on other forms of intelligence. What is on the left side of our chest is not just a blood pumping machine. Yes, it does that very well. But many traditional wisdoms across the world, they have always known that the heart is not just a blood pumping machine. It is a place of knowing. My heart told me. In many traditions and languages, there is the equivalent of that. But now we are being backed by neuroscience and other human sciences that actually, through the vagus nerve, the heart sends more messages to the brain than otherwise. So it's more than just a blood pumping machine. And again, many traditional wisdoms know that the space just below the belly button, sometimes that hosts our will, our capacity to tip into action. Let me just explain the enemies that stand in the way of unlocking these three intelligences. The voice of judgment, that little chatterbox that is in every one of us, that runs a commentary all the time. So when is this session ending? And when am I going to all that? So the chatterbox goes on. And that's how the brain is made. That's part of what it does. But what we know also that it has we have the capacity to suspend the voice of judgment. And what is the antidote to the voice of judgment? It's simply curiosity. When we ask questions, when we become interested in understanding that which is not yet clear to us, Tell me more. What's going on here? Who else should I be talking to? What will we know in future that we are not aware of now? Curiosity becomes the antidote to the voice of judgment. What tends to stand in the way of the intelligence of the open heart is simply the voice of cynicism. Cynicism is very close to judgment, but it's that fundamental disbelief in what is possible but not familiar to me. Because something is not familiar to me, I label it stupid, can't work, waste of time. The antidote to the voice of cynicism is simply compassion, the capacity to connect with other beings. In many traditional wisdoms, at least where I come from in Africa, I can be compassionate not only to you in the room in this space, I can also be compassionate to my ancestors. Just like I can be compassionate to those I will never see, but will call me their ancestor. And that's what creates responsibility. I can be compassionate to nature because in most languages, it's mother. The word mother is used to describe when we realize who we are and our relationship with the environment around us. We say Mother Nature. So compassion allows to push down for a period of time the voice of cynicism. What stands in the way of the intelligence of the open will, it is fear. Fear of not being in good books with my boss, fear of losing my job, fear of breaking our friendship, fear of all sorts. The antidote to the voice of fear, as you would expect, is courage. But it was Paul Mackay, one of the founders of Triodos Bank, who said to me, Martin, for me, courage is this. I notice fear. I feel fear. The next thing I try to do is to engage in dialogue with fear. Fear, why are you here? What is it that you are trying to alert me to that I may not be taking seriously? He says when he engages in dialogue with fear, fear doesn't go away. It simply occupies the right position it needs in his life so that it is not too big to scare him from action, but not too small for him to be negligent. And in a way, all I'm trying to say here is, I wish we could tap into these three faculties of intelligence. One, which is overtrained, the open mind. The other ones, which are less trained in our formal education system, open heart and open will. And then having the capacity to cultivate our quality of attention so that whatever it is that we are doing, we deploy the utmost of attention we can. And then we sense into the reality of our area of interest. The clues are not, you are excused if you are in the university environment, but if you are in a research program, the job is out there. Go and sense the world. Good farmers don't sit in their offices and then they say, where am I going to plant the next crops? They walk the field, they touch the soil, they smell the leaves, and then they realize they are going to move strawberries from here to there and cabbages from here to there. We need to sense the field. Go to the front line and talk to the other experts, and then create time. Create time to reflect so that you allow inner deeper knowing to emerge. And when some of the impulses become stronger than others, don't interrogate that impulse. Just act in an instant. Bring interrogation after you have taken the first action. And in this time of chaos, we will need communities from where we strengthen one another. And that's why I value this moment. Thank you.
You see why I told you my entire life story in the 5 minutes I met him, right? Thank you so much, Martin. Every moment spent listening to you moves me to another level of depth than I was previously on. So what a way to start the year, right? How fast Insaka of 2025 has put us in the right space. And to hear from people who've actually gone to the field, gone and touched the soil, a bit too hot of a soil, if I may say. We're going to invite our second set of speakers today. Normally, we try to clash, bring people who are, there's nothing in common, but you can already start seeing where this is going to end up. Our next set of speakers is the trio, called the explosive trio. Townsend, David, and Andy will give us a sense of what it feels like to be at the ring of fire. We're going to have a conversation on volcanoes, on geothermal power, and following that, we'll have an opportunity to ask the questions and have a really robust conversation. So with that, allow me to introduce the next trio. I don't know how you're going to do this, but they have 20 minutes. This is the next big thing, 20 minutes to do a three-person talk. So very excited about this. So allow me to, we're gonna do this next time, yes? This is for the next talk. Oh, I love that. Can we do that later? We'll do I promise you we'll do that, yes? Okay. We will do that when this talk is done. So good. Let's have the explosive trio. We'll start with Hamdi. Welcome.
Thank you very much. So we are going to present on Ethiopia's volcanoes, rift volcanoes, including human history and geothermal features. For my part, I will try to go through nature of volcanoes, and I'll try to associate with the hazards linked to volcanic activity. So volcanoes are surface manifestations of the Earth's internal thermal process, producing products in a form of solid, liquid, and gases. And how and why volcanoes are forming? We will go deep into the Earth structure. Our Earth is layered into three: core, mantle, and crust. The top part of the Earth layer is brittle and rigid, which is called lithosphere, and below that is anasterosphere, which is more ductile in nature. This rigid part, the lithosphere, is broken into large pieces called plates. And these plates interact in a way of coming towards to each other, going away from each other, and pass to each other by forming a good condition for melting of rock and rise to the Earth's surface to form volcanoes. That's why most of volcanoes are aligned to these green lines, as you can see in here, which are called plate margins. If we zoom into the East Africa, we will find a prominent natural phenomena called the East Africa Rift Valley. In this part of the world, there is tearing apart with 4 to 6 millimeters per year. And it starts from Mozambique in the south and goes all the way to Afar, covering up to 3,500 kilometers. It branches into two, the western branch and the eastern branch. The eastern branch passes through Kenya and goes all the way to Ethiopia. And the Somalian plate is pulling away from the rest of the continent. And in further north, the Arabian plate, which is pulling away from the Somalian and Nubian plate by forming a Y kind of configuration, which we call it rift-rift triple junction. which is located in Afar. When we go northward, the rift is getting matured. In the south, it's typically characterized by faults, which are a typical nature for an early stage of rifting. Further going to the north in Kenya and Ethiopia, there is an involvement of magmatism in addition to faulting, which is a good indication of tectonic stretching. But in Afar, this becomes more advanced, and the lithosphere becomes very thin and almost zero in thickness, which is an indication and representation of onset of seafloor spreading. The Metopia Rift links the Kenyan Rift in the south and the Afar Rift in the north. It's demarcated by a series of cliffs that separate the highland from the lowland, which is a rift floor in here. And in the axial zone, it hosts large volcanoes, mountain volcanoes, which are spaced regularly along the axis. And also includes other eruptive centers, which are really small, and they are controlled by these lines, which we call them faults. These volcanoes, large volcanoes, hosts a depression, we call it caldera, which is a representation of these volcanoes underwent big eruption in the past. After this big eruption, there are several styles of eruption activities happened in these large volcanoes with a different frequency and magnitude. In Afar, most of the volcanic activities are happening in a discrete magmatic segments, such as Ertali magmatic segment, Tebahu Mandahararu segment, and Asal, Tubet, and Manda Inaker magmatic segments. The Ertali magmatic segment represents all land representation of the Red Sea Rift, which is indicated in here, with almost zero thickness of lithosphere. And it hosts the longest living lava lake in the world. And when we come to the Debahu Mandahararu, it's well known by its 2005 to 2010 rifting episode, which implaced around 13 magma intrusion within the 5-year period. And only the 3 of the magma intrusions survived to the Earth's surface and caused volcanic eruption. Some of the recent studies, spatial geophysics and geochemical studies, indicates below the axial zone of this rift, there is 2 pool of melt zones exist, which is feeding all these eruptive activities, which we call them transcrestal magmatic architecture in most of these active volcanoes. The shallow one is located around 3 to 5 kilometer depths. The one which is the voluminous one is located deeper than 10 kilometers and goes all the way to the mantle. This architecture is also visible in Afar Rift, but the volume of the magma becomes much larger compared to the Metopia Rift. So most of this volcanic eruption pose a lot of hazard to the surrounding community. After an eruption, during eruption, or even during the making of the eruption. To give you one example, recently there is a seismic activity happening in the northern part of the Metopia Rift in Debahu, in Dauphin and Fentali magmatic segment. In this area, there is a seismic activity started. Seismic means earthquake activity started in late September, and then it ends in early October, which is mainly caused by an intrusion of a magma, which is a molten material to the beneath Earth, with a volume of 0.08 cubic kilometer, which caused Earth to inflate with a displacement up to 2.8 centimeter. The second activity started in late December, and then it is still happening now, which caused by a magma intrusion with a volume of around 1 cubic kilometer, which caused the earth of the ground around the area to uplift up to 30 centimeters with a radius of 10 kilometers spatially. And during this time, there was a lot of things happened in terms of destruction, which demolished more than 30 houses around the region and caused to evacuate around 100,000 people from the nearby area. And some of the roads which connects the district, the area, is damaged, and there was some systemic damage to infrastructure which is located close by. By saying this, I will pass to David. Thank you.
So I'm going to follow on that just by talking a bit more about the information we can get about the past by looking at the geological deposits, the deposits of past eruptions along the rift. And one of the features of the very large volcanoes along this rift system is that they've had enormous explosive eruptions. Those eruptions are rare, they're spaced many tens or hundreds of thousands of years apart, but they leave they leave a dramatic record in the geological past. So many of these caldera volcanoes, these are craters which are 10, 15 kilometers across. In fact, some of those craters are sufficiently large that you don't actually realize they're craters. So these are the locations of where the magma was erupted, and in many cases the material that's erupted is then dispersed as volcanic ash around the region. And over the last 4 to 6 million years, we know that there's been explosive volcanic activity of this style, and it's very likely that these volcanoes have provided the resources that people have then used to make tools, for example, obsidian, and then equivalently, the volcanic ash layers themselves are the layers that can be dated and that can often preserve the horizons where we find the remains of ancient hominins. So this is the cradle of human civilization, and the chronometer, the clock that we can use, are actually these volcanic ash layers. Yeah. So here are two examples of volcanoes. Up on the top volcano is a volcano called Aluto. We're standing outside the volcano, and we're looking at the edifice of the volcano. It is quite a young volcano, and the crater of the volcano is actually behind that ridge. The bottom photograph on the left-hand side is a view inside the Corbetti caldera. The edges of the volcano are small cliffs, in this case, of volcanic deposit. And the interior of the volcano is filled with volcanic deposits and sediments, which provides a fertile place for people to live. So there's been long coexistence between volcanic structures, the volcanic products, and people through the Ethiopian rift. These days, we can monitor the state of the volcanoes from space. This is just an example of combining satellite information about the volcanoes that are deforming that we can't necessarily detect them deforming as we're on the ground, but we can see that many of these volcanic systems, from the color fringes, this tells us that these volcanoes are actively changing shape. And the way they change shape tells us about what's going on inside them in terms of fluids. So the work that we've been doing in the African Rift over many years with many colleagues, one of our former graduate students is here in the audience, is that we've actually been trying to understand the life cycle of a volcano and how that then feeds back into the landscape that we find in these rift environments. So in a typical volcano, we're looking at a volcano called a Luto. The history of the volcano starts more than 2 million years ago. We have some rifts, some fractures that start to open up in the valley. We have the development of an old volcanic system. And then over the next few million years, the rift system continues to extend. We imagine that there's magma rising up, which is feeding into these fracture zones and helping the volcanoes to build. And at the same time, because of the way that the climate system is developing around us, as we're opening the rift, we have episodes when we have large lakes within the rift system, and other times we have times when the lake systems are rather smaller. Around 300,000 years, we now have the development of our new volcanic system with violent eruptions and extending deposits out into the lakes across the rift floor. And then this particular volcano, Luto, goes quiet. We don't see any evidence of how that system is behaving, and it's probably quiet for maybe 250,000 years. And then for the last 60,000 years, this volcano Luto has become active again, with magma feeding into the inside of the edifice and the volcanic system continuing to grow. So these volcanoes, we can imagine them having a life cycle. They spend a long time in a juvenile phase. They reach a period of maturity, a catastrophic episode of magmatism, and then they have a long period when they're of quiescence or senescence as they get older, and the magmatism changes as a result. And all of these processes we can interrogate, we can understand by reading the rock record, and they all feed into our understanding of what happens next. So I'm just going to close with a photograph. I think this might be Amde in the photograph, and a study that Amde was involved in. So the sorts of things that geoscientists do, literally, we read the rocks. And in a volcanic sequence, volcanic eruptions produce rock fragments that accumulate on top of each other. We can see within this sequence here, it looks like a riverbed because it's a river that's cut through some volcanic deposits. But as a volcanologist, we see that these are different layers which are produced during different episodes of volcanic activity. And we can produce block diagrams like this, which to a geologist says this is how the volcano is changing its behavior over hundreds of thousands of years. Now, in this particular study that Amde was involved in, it was a really nice piece of work because the ash deposits contain minerals that allow us to be able to date the age of the minerals very precisely. And below this unit are the first fossils of modern humans, Homo sapiens. And in this particular case, the scientists collected many crystals, dated them, and determined that the age of these units is around 230,000 years. These are immensely old deposits, and they tell us about the start of the origin of Homo sapiens. So from the past of volcanoes, I'm now going to pass on to Tamsin, who's going to tell us a bit more about futures.
So Andy and David have talked about hazards and people's homes being destroyed, and then about a process that's going on over millions of years or thousands of years. And I'm now going to bring us right back into the here and now. So I'm going to be presencing in your words. We're going to be properly doing that. So some of the information that we put together from the ash layers, from the past eruptions, from those kind of colourful maps that you saw with the volcanoes changing shape, but also from walking through the African environment and making gas measurements and the cores that people have drilled into the volcanoes in East Africa, actually allow us to put together these subterranean maps. It's a bit like detective work, if you like, to work out what their structure is underneath the volcano. And one of the things we find, as well as magma, that's this red blob down here, we also often have hot geothermal fluids. So these are watery fluids that have flowed in from the sides of the rift, fallen in rain, or from the lakes, and then they percolate down into this hot zone close to the magma and get heated up. And we can see their presence by the gases coming out, the way the volcanoes change shape, amongst other things, and measurements like springs and hot springs and mud pools. Now, the exciting thing when you find these hot fluids here is if you drill down into them, you can harvest the hot fluids and you can get power out of the hot fluids. And this is basically the source of geothermal power. And this is actually an enormous opportunity for East Africa. So volcanoes are hazards, but they're also opportunities as well. And this is a picture of the Aluto power plant. So David has talked about Aluto. If you go there, there are these kind of silvery pipes running over the landscape. It looks really out of place. And then you have these kind of up some of the valleys, you have these steaming vents. And these aren't open volcanic vents. These are drill holes that people have drilled in order to get hot fluids out of the earth. And you can see an example of it here. And there's actually Ethiopia's only geothermal power plant at Aluto, which is a 7 megawatt power plant. So Ethiopia actually doesn't get very much of its power from geothermal. It gets quite a lot of it from hydropower, some of the dams, some of which are reasonably controversial in the northern part of the country. But it just has that 7 megawatt power plant in Ethiopia, but a much higher target capacity. And actually, Corbeti volcano, which is one of the other volcanoes David showed, there's an ongoing project to try and construct a 70 megawatt plant. So it's a massive opportunity. And the exciting thing is, as well, is right next door to Ethiopia and Kenya, you've got a world expert, a world leading country in terms of geothermal power. So Kenya is in the top 6 in terms of the geothermal power it produces. This is from a trip to a Kenyan geothermal plant. This just shows you a little bit about how a geothermal power plant works. I'm not going to go into it in very much detail, but just a few things. We get the hot water out of the ground. It's not that hot water that we use to drive the turbines. It goes into a heat exchanger, and then it's the water that's circulating around. And then one important thing to remember is that in most projects, not all actually, they re-inject the fluids back into the subsurface. So you're not drying out the subsurface and you're not actually taking things out. So you've got a circulation of fluids out of the volcano and into the volcano using that volcanic heat. And then a separate circulation that actually drives turbines and generates electricity. And in Kenya, we've got a couple of examples here. So we've got Olkari, which has got a 275 megawatt capacity already in progress. And then they are developing at Menengai a 130 to 400 megawatt power. As I say, it's like really in the top 10 countries worldwide producing power, and also has really great training, so a master's course and such like for training people. The other thing to remember with geothermal power is we get other opportunities as well. These are again some examples from Kenya, but also a country like Iceland. If you go to Iceland, I think Iceland is actually the biggest banana producer in Europe, which is obviously maybe slightly surprising given its climate. And that's because they use the geothermal power to power greenhouses. Some of the Icelanders really complain about them because the lights from the greenhouses spoil their summer house views and things like that. But if you go around Iceland, you'll see all these greenhouses powered by the geothermal power, basically producing fruit and vegetables that really should not be produced in a country like Iceland. So this is our colleague Marita showing around basically this is an agricultural bed based on the energy that you're getting out. You can do refrigeration. You could do freshwater agriculture, you could do greenhouses, and this is an example of all the kind of direct benefits you can get, as well as generating the electricity. So there's a lot of potential. Kenya has really realised it. This is a map using various different input parameters and a GIS approach to work out where the biggest potential is. And you can see all down the East African rift that Andy so eloquently introduced. We have the potential for further geothermal power. So it's actually a very exciting prospect and something that's really underused in East Africa. And you've got a country with key expertise there in terms of Kenya. Finish.
This is a fast. I mean, we usually have one speaker who goes on for like 45 minutes. This was 3 speakers. But man, I kind of we went all the way to the skies and took satellite pictures and went all the way to 230,000 million years ago and came round back to my beautiful country in 20 minutes. I am super impressed. How wonderful. I hope you enjoyed those very brilliant talks. Can I kindly ask our speakers to come? I hope you're ready with all your questions. We are very much in time, so we've got about half an hour, 20 minutes. You better behave as well as our speakers did today. So have one question succinct, very well thought out. We'll have opportunities for questions and a discussion. And it's been fascinating to hear how the talks come together, giving us a chance to really dig down into what it looks like to do research from a place of presencing, as it were. So I'm excited about this. Let's see what questions come up. Shoot your hand up and then we can get started.
We got one here.
Oh, we've got one already. It's written down. Okay. There is a dialogue happening. You ready? Okay.
The 3 people who talked about the volcanoes, how do satellites detect how bad the volcano eruption will be?
Okay. How do satellites detect how bad a volcano is going to be? Do we have another question for the volcano? Okay. He's opened the door and opened the mic. Now I can see hands. If you can't ask a question, then I don't know what to ask.
Okay, thank you so much for the presentation. My question is about thinking into the future. So the 3 steps, thinking from the mind, the heart, and I guess like the will. I'm just curious, in the current world that we live in, where you talk to somebody and you tell them, oh, these are my thoughts, and they're like, okay, where's the data? Where's all of this? And then you also go on and you say, yeah, I have this gut feeling. This is what my heart is telling me. How do you approach such a conversation, especially what we've learned? And then the second question, which is connected, is how do you nurture your heart and your will as points of knowledge?
Okay, we know how to nurture our minds. That's why we came to Oxford. How do we nurture the rest?
Thank you for the presentation. It's actually to the 3 presenters. Is there potential to share the power that's generated from volcanoes? So for hydropower, you can share it between countries. And I'm asking because Kenya's got like good capacity, but there are countries around Kenya that might be able to benefit. So is anyone looking at that as well?
How much is it and how useful can it be? Let's start there so that we don't overwhelm our speakers. Ask that first and then we'll have a second round of questions. Yes, so get those ready. Over to you.
So I guess start on satellites. So satellites are very, very powerful because we can see almost the whole planet with satellites, which is really lucky because volcanoes are over all the world. One of the best ways of working out how bad a volcanic eruption is going to be with the satellite is by how much the volcano is swelling up. So before an eruption, volcanoes sometimes swell up like a big blister and then they burst. And the more they swell up, the bigger the eruption, roughly speaking, but not quite, but that's approximate. And it's actually really clever the way satellites do that. So I don't know if you've heard of something called radar, which sends a beam out, and it has a wavelength. What these satellites do is they send a beam out and it reflects off the Earth, and they look at what part of the wave comes back. So is it a crest or a trough? Which part of the wave? And then like 10 days later or 2 months later, they go around again, they hit the same place with the beam and they look at how that beam has changed. So does a different part of the wave come back to the satellite that time? And you can overlap those two waves and you can work out whether the ground is moving towards you, staying the same, or moving away from you. And that allows you to work out how big the blister might be that then might burst and give you an eruption. So it's a great question and it's a technique we're very, very excited about. And you get those nice rainbow diagrams.
Wonderful.
Thank you. Two great questions there. Please do remind me if I do not answer the two questions clearly. We need the data, but it's not data that is merely gotten because of literature review. It's like our colleagues here, you saw them on the soil. You saw them like it were in the trenches. If you are removed just because you're analyzing the data on the screen and the reports that have come online, that is not sufficient for certain types of transformation we need to do in society. We need to step into, like old anthropologists or volcanists are doing. They go there, they see, they feel the soil, they see the rock, they smell the dust that is there. That's what we need. And in policy making, and you guys here will immediately go into policy making. If you are already not there, you cannot just do that through desk review. But more so, when you have the power to make decisions, you need to be on the front end. So the data I'm talking about includes, yes, what our scientists are doing here, but also personal experience so that you learn differently. And how do you train this, the heart and the open will? The heart is, as I said, trained by compassion. Many of you in this room who have had the chance to listen to me talk about this will remember the story I always tell. When I had the privilege to serve as special consultant to the third president of Zambia, I would never give him just these papers to sign off. I would always take him to the place where he could experience something before he appends his signature on the new policy, on the new bill to turn into law. I talk about this moment when the biggest meeting in terms of cabinet was going to be on the growing army of children on our streets as a result of HIV and AIDS. And fortuitously, by the same token, I had come to know that an orphanage had opened just nearby the president's home. And I went to the president on Friday and I said, could you spare me some time tomorrow? He said, Saturday is my resting day. Why? And I said, it's because I would like you to visit an orphanage. I said, imagine, is that a good use of presidential time? But somehow he gave in and he gave me a directive. Exactly 30 minutes you take me out of there. If you have worked in government, you know that's a directive. We wound our way to the orphanage in the morning, and typical African style children were dancing and ululating to welcome the visiting head of state. He quickly sits in a circle with them. My job as per tradition is to sit behind him. 15 minutes down the line, I write on a piece of paper, 15 minutes to go. I give him the piece of paper, he crumples it, he gives it back to me without looking at me. 5 minutes before the end, you're supposed to give him notice so that he winds down his interaction. 5 minutes to go, I wrote. He looked at the piece of paper, crumpled it, gave it back to me. He doesn't look at me. It's 30 minutes. He looks like he has just begun. I made a judgment call, I could give him another 10 minutes. He's not slowing down. As boldly as I could write with a pen, I wrote, we are 10 minutes behind schedule. This time he looks at the piece of paper, he doesn't crumple it. In full view of everybody, he screams, Martin, what's the problem with you? I am talking to children and you are hearing me out. You're hurrying me out. At that point, you have lost all influence on your boss. He is now on what is known as presidential time. We were leaving the orphanage 2 hours later. And as we were scampering to our vehicles, he called that I join him. Before I could even buckle myself in the seat, he screamed, "Come on, Martin, what kind of country are we running? If in the 3 years that I've been head of state, we have never talked about those children." At that point, I knew that I had communicated to my head of state. The following Monday was a completely different cabinet meeting. Why? Because the children were no longer statistics. They were Irene, Michael, and Muila, and Mutale. It was a different conversation in cabinet. This is what I mean by open heart, the intelligence of the open heart. I couldn't have given him, by putting a report to him on the desk, he needed to be in the space. Courage. All of us have to know that the future we want to create is not clear. So what do? We are doing this, lifting our foot and stepping into this thing which is not yet known. What allows us to have an intelligent case is when we have opened our mind, heart, and will, and all the data that these scientists are working with. It allows us to make an intelligent guess. But nevertheless, where we are stepping next, we don't know. It just gives us a clue that we might just be right. Sorry for the long answer.
We have enough power to power the whole East Africa.
So, I mean, it's possible to share the energy and the electric energy between the different countries. But, I mean, it didn't happen for the geothermal energy produced from the geothermal energy electricity. But I know there is a talk between Ethiopia and Kenya regarding the hydrothermal energy resource. Of course, it's not for free, but there is a way of selling it to the other countries.
While you're thinking of that, I want to maybe tease out that a little bit more. We still have about 600 million Africans, about 43% of our population lacking access to energy. What's going on with all this free, I would say, like natural provided? What are we missing? What are we missing in the equation? I'm not an engineer, but I'll be curious to hear what your thinking is on that. A few more questions and then, yes, there.
Yeah, I think it does a follow-up question from what you just said. Just wanted to ask the future of geothermal in Africa due to like lack of access to electricity first. Secondly, from the investment side, what do you think African leaders can do to scale up investment? Because there is a lot of political instability which chases away investors in Africa. So I mean, like, I don't really know if I put it all, but these are the questions. Thank you.
Good. There was a question over here. You had your hand up for quite a while. Over here, to the front.
Thank you for your talk. This question is for the three presenters. You mentioned the impact on humans, so I just wanted to find out if your study also looks or tracks the impact on animals, like mammal species, fish, aquatic species, bird species, and how the transformations of the landscape affect their evolutionary processes and dynamics, and if it does, maybe just explain a bit on those dynamics.
So really, really good question. And one last one before we close.
Thank you for the good presentation. So to the three presenters, my question is on, as a young person, if you're interested in geothermal power, how do you start the conversation with your government and bring in that agency that you need for them to act?
Some excellent questions there. So I'll address the question, which was about how do we track the impact of volcanic eruptions on the landscape and on animals, for example. I think this is an area where we know in general, we know very little because we've not normally been in a position to be able to go out and make those measurements on short timescales. But it is an area where there's a huge wealth of stored data, which geoscientists will be trying to access. And some of those data are stored in chemical records or rock sediment records within the lakes of in Ethiopia, for example. Because by studying the nature of the deposits on a very fine scale, you can see what was living in the lake, you can see what was happening in terms of the water cycle, you can see what the rock materials are made of. And so you can start to tell the story of how climate has changed over 4 million years and how populations of how different plant species have changed over millions of years, because you can see the pollen grains changing and so on. And so certainly there are many geoscientists and some leading scientists in Ethiopia, for example, in particular, who are actually looking at those sorts of studies. So we're looking at I guess we're using the fingerprints of what scientists would call them proxies, I guess, but we're looking for fingerprints that are preserved in a record. And for me, the volcanic ash layers within there help to provide the clock, because we can date those events. I'm just going to add one additional thing which I was inspired from Martin. What Martin was saying is that, so as scientists, yes, we go into the field and we collect data, but actually one of the things that I find appealing about working on volcanic systems is that volcanic eruptions produce the same sorts of materials wherever you are in the world. So you can walk up to a new deposit in a new country, a new location, and you feel right at home in a very strange way, because the rocks next to you are familiar, and you can identify, you can see from, you know from them instinctively from the nature of the material, you know how it got there. And the scientists, we don't write about this. We explain how we make the measurements, and we use the measurements to validate our observations, but actually your instinctive reading of the landscape comes from your past experience in other landscapes and your present experience in a new landscape, seeing how things fit together, and you carry all of that together, with you as you go on to your next place.
That's such a lovely point. I think actually the first time Andy and I met was working on a Luto volcano, and it really challenged me, because one of the things I remember about that trip is we were looking at gas coming out of the ground, and we had to move very, very slowly through the landscape because we had to make a data point every few meters. And it's very rare to move that slowly through a place, and I became very intimately knew that area very well. You start noticing lots of things about a place that you wouldn't otherwise notice. So that was an interesting experience as a scientist too. So to come on, I think there were two questions, but we're kind of on the same theme, and then Anna's question too, about geothermal power. So there is a lot of CapEx, so capital expenditure up front to get these plants up and running, which is a big challenge. And it's not just a big challenge in Africa. We're involved in projects in the Caribbean as well. And some countries, I think, they find ways of de-risking it. So Iceland is a good example, and Kenya has obviously found ways as well. But there's a lot of exploration that has to go on first. The start of that picture actually that I put up of the cross-section for Aluto is one of the figures from Will's PhD a few years back now. But you start off by getting the information you can from the ground itself, just by doing what Andy and I were doing, walking slowly through it and doing the satellites that we've been. And but then you need to drill, and you have to drill and find out whether you've got good prospects. So that's where, once you start at that stage, then lots of money needs to, and there has to be proper contracting. So you're right, political stability is absolutely key, and that's a problem actually at the moment in Ethiopia, which we're grappling with. And then investment, and good investment in terms of structures that mean that the money just doesn't flow out of the country, the money is in the country too. schemes such that the local people, so some of those schemes we saw with the direct power use, so the schemes such that local people see the benefit as well, rather than the power just being taken away and generating jobs. And then education too. So I think that's something that Marita in Kenya has done a fantastic job with, having the master's programme. So there's a whole pool of homegrown talent now. So I think those are 4 really strong points that I would put out there. And I think the question about political leaders and how you get involved as a young person and get your politicians interested. So I think demonstrate, the good news story of Kenya is a great one. You've got a kind of poster child, if you like, for how it can work, but there are plenty of pitfalls and there are plenty of challenges too.
Yes, okay, so we have 5 minutes left. With the permission of David and Chimwemwe, can I abuse my power and just spend 5 minutes on, we've learned a lot about how to be, a scientist who's present. I want to abuse my power and ask Martin to go with us through the journey of learning from an artist, because I think it's really powerful and brings the conversation to a good round circle, if you don't mind me putting you on the spot. Yeah? Yes, please.
So this is just one way of explaining. Thank you. One way of explaining how natural it is for us to learn from the emerging future and act in the present moment. But it is artists who sort of remind us of this natural aptitude that we have and may have lost. During the World Cup in Rome in 1990, the 3 tenors were invited to perform at the opening of the tournament. Like in all cases, people who are performing at the opening of the World Cup are informed 2-3 years even that they will have a role to play. In this particular case, the 3 tenors knew 3 years before that they were going to be opening the show. But unlike all of us, when you know that 6 million people are going to watch you live, what do? You choreograph as much as you can so that you reduce the mistakes to as much as 0. In this particular instance, Zubil Mita, the conductor, is leading with Placido Domingo, the tenor. They had done this for 2 years. I would like you to pay attention to who is leading who, as well as to their quality of relationship. It doesn't work because for some reason the voice and the image are not synchronizing. I guess it is, I don't know, the nature of the connection. Let me do that and then try again. No, it doesn't work. So the whole deal is simply this, that Placido Domingo, consumed by music, he goes a few notches longer than they had practiced for 2 years. And Zubil Mita, the conductor, when asked by my colleagues, what experience did you have? He said he experienced 2 impulses. 1, cut the whole thing short to manage risk, or to trust that Domingo wouldn't want to spoil the party. He is as vested into this as I am. But then deal with the consequence of being taken through the unknown. And he said he went for the second option. So you see a conductor who is paid for doing this, In that moment, when he gets to the unknown territories, because Placido Domingo's voice has gone a few notches longer, you see him go like that. And the only thing that he does next, he opens himself up completely to face his tenor. So the magical ending you hear was never practiced. It emerged on the floor with the full risks it takes to experiment something when 6 million people are watching you live. And for me, this is the world in which you are functioning, we are functioning. We will not let the scientists finish their private investigations under the table. We will follow social media and everything else. And they have to do this delicate work in full view of everyone. Just like you will not have the pleasure of making experiments under the radar because everything is in the open. It's a very different skill. And that skill only works if you believe in collective and open leadership. Thank you.
It's usually my job to end with a big finish, but I guess this wasn't my job today. The reason why I think it's really important for us, and we will hope to send this along at some point, and you can see it in action. The reason why I think it's very important for us to start the year, and I know for us academic years and calendar years are different, but for us to start the year with such a time of such trepidation, anxiety, curiosity, it's almost as if we're walking into a live volcano, you know? We don't know what it is that we're anticipating. We don't know what it is that this year might bring, but we at least can begin cultivating that sense of our open heart, an open mind, an open will, and bringing our research expertise, our curiosities, the thing that brought us to Oxford. We can bring it to bear in our work. We can make our work more meaningful because we're doing it for a particular reason, for a particular cause. It's beyond us, but it is for us and with us and within us. So I'm really excited about what the year brings for AfOx, for our community, for our students, for our researchers, for our innovators. It's an exciting time. And more importantly, I know we're going to journey that journey together. So with that said, I want to welcome you specifically and humbly for the next Insaka. Maybe we talk about how we finance nature. I don't know. Maybe we talk about how we move from where we are to where we want to be. I don't know, come and find out. Take that curious step to join us for the next Insaka on the 9th of May, and bring your friend, tell a friend to tell a friend. And as I said at the beginning, do join the broader conversation of AfOx. We have lots of events that are happening throughout the year. We have calls for application, for funding, for food, for community, for an opportunity to share these ideas with each other. So do come and do join. And so for me now, at exactly 6:53, I was told to end by 6:55, so I'm so proud of that today. For me, allow me to say a big thank you on my own behalf, on behalf of the AfOx team, and on behalf of our entire community. I hope you enjoy the drinks afterwards. Don't rush off. Have some time to engage with each other. And it's Kwaheri from me, and we'll see you at the next Insaka. Thank you.
Yeah,